Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 47 in our incredible tutorial series where you're learning artificial intelligence on the Jetson Nano. I will need you to pour yourself a nice big mug of iced coffee. And today I will be also enjoying some hot coffee. The iced coffee is a prerequisite for this lesson. The hot coffee for you is optional. Okay, I will also need you to get out your Jetson Nano gear. And as you are getting out your gear, as always, I would like to give a shout out to you guys who are helping me out over at Patreon. Your support gives me the encouragement to keep this great material coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. But enough of this shameless self-promotion. Let's jump in and let's see what we are going to learn today. I do believe, if I remember correctly, at the end of lesson 46, we had two cameras working together using our newly found Python skills of classes, methods, and threading. Remember, a function that's put inside of a class is called a method, so don't be intimidated by the word method. It's just our old friend, a function. And then threading allows us to run multiple functions at the same time, kind of independently of each other. So we learned how to do that. And at the end of lesson number 46, we had two cameras in OpenCV running together in sync without latency or lag between the cameras. Pretty big accomplishment, I would say. But then what your homework was to go in and with two live streams coming into OpenCV to do facial recognition, facial identification, to be more specifically, on the images coming from both cameras. And so that, my friend, is what we are going to do today. And I will get out of your way. And then let's come over here and let's open up a fresh new Visual Studio Code. And if I remember correctly, and I think I do, we were working in the PyPro folder, and then we are working in the Face Recognizer folder, okay? And then we're going to create a... are we working in Face Recognizer? I really think we are working in Face Recognizer. Okay, we are working in Face Recognizer. We're going to create a new file, and that new file is going to be Face Recognizer, and this will be program 8, and this will be, we'll call it twin. We called the last one twin cams. We'll call it twin face, because it's finding faces in twin cameras. My file names are getting a little awkwardly long, but I like to put something in there. I like to put the numbers so it's sequential with the series, but I like to put a little tag so if I come back later, I will say, now how did I do that? I can quickly find the program. Now let's get the, excuse me. Again, cleaning ladies are putting bleach on everything. Makes me a little wheezy, you know. I will get the File Explorer out of your way. I believe you have a pretty good view here. And what we're going to do is we're going to go ahead and start where we left off in lesson number 46. You probably have that code. If you don't, you can hop over to the most excellent www.toptechboy.com, and you will want to search on AI on the Jetson Nano lesson 46. You can use that little button to search. And then I have the code here that I ended up with at the end of the last lesson. So I'm going to Control C to grab that. I'm going to come over here and Control V to put that into the browser, and I'm going to get rid of some of this awkwardly long white space out of my program. Okay, so let's run this program just to make sure that something hasn't broken between last week and this week. So we will right mouse click, we will run Python file in terminal. You notice once I started doing a lot of these library loads, I stopped holding my breath when I run the program, because some of these things take a few awkward long seconds to get it working. And boom. Okay, so let's see. It looks like those cameras are working together, and we're getting a nice high frame rate and no lag between the two cameras. And if I look to my picture in the bottom right, you can see that between the cameras and real life, there's just a little fraction of a second latency, but we can live with that. So let's queue out of this and let's get ready to do some new stuff here. All right, so let's look at our libraries. First thing we're going to need to do is we're going to import these libraries that we already had, but there's a couple of more things that we're going to need. We're doing face recognition this time, so what do we need to import? We need to import face recognition. That looks good, and I got to spell import right. Import face recognition. You ought to be familiar. We've used this in the past. And then also, because we're doing facial recognition, we got to load our training data. Now remember, if you haven't done those earlier lessons, you've got to do that program that trains, okay? Because remember, our training program looked at a folder full of images and trained on those images. If you haven't done that, then you've got to go back and do those lessons. So import pickle, because we saved our training data in a pickle, and we're going to have to load that pickle in, which means we've got to use the pickle library. All right. Now, I believe down here I am going to be calculating a frame rate, so I better put DTAV is equal to 0, because I think that's a variable that we'll use later. D is change in t, DT, change in time, and then AV, average, because we're going to run a low-pass filter on it. Okay, now we're going to say the font is equal to CV2.font underscore Hershey simplex. That looks really good. Kind of knew that. Liked how it guessed that. Okay, that looks good. And then we've got to go out and we've got to load that training data. So we're going to say with open. Okay, and what are we going to open? We are going to open our pickle file, which we called train.pkl. Okay, train.pkl, and then comma, we're going to open it as a what? As a read bytes, RB. Okay, now we're just going to open that as F. Okay, we're going to open that as F. And now to load the things, to load our training files, the first thing we're going to load is names, and that's going to be equal to pickle.load. Where are we loading from? F that we just created. And also we are going to have encodings. Encodings is equal to pickle.load. Where are we loading from? F that we just created. Okay, at this point we should have our training data loaded in. Okay, so now we're going to come down, and I do believe that we're just going to keep this the way it is. We're going to set up our vStream class. When you create an object using vStream, what does it run? It runs the init, okay? And then we're going to pass that function. We're going to pass that class with the source, that's which camera we're going to use, and the width and height that we want. Now we've got to take those pass parameters and make them parameters for the class. So we say self.width is the width you were passed, self.height is the height. And then here, self.capture, we actually launch the camera, and then we start our thread to make the measurement. That all looks good. Then we come down here and we say this is the update. We launch this method in a thread called update, and then what does update do? It just sits and reads the camera, and when it grabs that frame, then it resizes that frame. Okay, it resizes the frame, and then we have a method that is called by the main program, which is to go up and grab a frame. So that thing is sitting there taking frames constantly for however many cameras that you create using this class, and then when you want a frame, you just directly call the method getFrame, and so you can go run up and grab a frame whenever you want from the main program. Hopefully that makes sense, because we've gone over this fairly exhaustively in our earlier work. And so let me get things lined up here a little better. Okay, and now let's see, we have flip is to display. Very good. We already have that long string that is needed in order to launch the Raspberry Pi camera. And then with that string, we are going to first of all launch cam 1. Cam 1 is going to be the webcam. And then cam 2 is going to be the Pi cam because we're passing it cam set. Now in both cases we want the frame to be 640 by 480, so we pass those. So cam 1 is going to call that class and it's going to create a camera object which is going to be called cam 1. And then the second camera is going to be cam 2. Sort of makes sense, doesn't it? All right, now let's keep looking here. We've got that. This start time is so we can calculate frames per second. We're just kind of grabbing a reading from the clock so we can start timing how long it takes to go through our loop. And here is our DTAV down here. So in fact, I did not need to put it up here because we already had it. All right. We did it down here and we don't need to do it more than once. Okay, and look at that. Did we already set the? It looks like we also set the font down here as well. So we don't need to set the font more than once. So I did not remember that we had left those nice little things in there, so we will leave it like that. Okay, now one more thing that we are going to need to do. Remember that when we start doing face recognition, we want to do it on a smaller image so it'll go faster. So how far do we want to scale down the image? The further we scale it down, the more small faces it's not gonna recognize. The greater we scale it down, the more it just finds big faces, but the faster it runs. So there's a trade-off between running fast versus finding smaller faces in the frame. I think we've talked about that before, but we're gonna go ahead now and say scale factor. Scale factor is equal to, I think 0.3 is a pretty happy medium. Okay, and now we're going to go ahead and this runs out and gets the frame from cam 1, we get a frame from cam 2, then we combined the frames from the two cameras, we NP numpy horizontally stack them to create frame 3. That all looks good, but now that we have frame 3, now we're going to start doing the facial recognition. Okay, so I should say a couple of things at this point. You can see that there are different ways to do it. Another way could have been up in that class, I could have created a function which is like find, or a method which is find faces, and then anytime I go to grab a frame, I could have had it then call that method, and that way it could have been up in the top, and I could have even like started some threads up there to be constantly finding the constantly finding the faces in the frames. I could have folded this into the methods up at the top, or I could just say, all right, it's not a big deal, I've got one frame, all I got to do is just now find the faces on that one frame. And that's kind of how I'm going to do it. Now also what I'm going to do is I'm going to go ahead and run this thing just to make sure that we haven't broken something already. This early in the game we've already broken something. Okay, and I'll talk to you a little bit about debugging here in a second, because we're getting into some programming where the troubleshooting and debugging gets a little bit harder. Okay, hoping those are just those normal warnings that we get. And remember, it takes a little while to get this thing kicked off, so we're not going to panic yet. Okay, there it goes, boom. So no big deal other than we just haven't broken something. Let me just take a second and talk to you about why this is going to get hard to troubleshoot. Okay, so when we come down and jump into this grabbing frame, right, the program like launches the camera, launches the thread, does all that sort of stuff. What happens if we give those commands to launch and then we get down here and we try to read a frame, but the camera hasn't quite fully gotten launched yet? We would get an error, and that error would crash the program, where there's not really a problem in our code. It's just we tried to read a frame before a frame was ready. And that's why in things like this we say try and accept. And that way, if it tries to read a frame and the frame is not there, rather than the program crashing, it just goes back. It comes down into accept and says, well, okay, I couldn't make it through the try, so I'll print whatever you want to print here, and then it goes back and tries again. So what will happen, you might have a no frame, no frame, no frame, and then boom, everything works. That's why we do the try and accept. And let's see, it doesn't look like it was really needed here because it looks like it didn't actually go in. When it tried to grab that first frame, the first frame was ready. So, okay, that's good. Okay, so you see why we do try and accept, but what is the problem? The problem now is, like, let's just say mess up equal C7. Okay, there's no such thing as C7, so the program is going to crash there. So let's see what happens. Right, there's no C7, so that's going to throw an error. And let's just give it a second here. Okay, so you see now I'm getting this frame not available, frame not available, frame not available, but I don't have a clue why it says frame not available. It has nothing to do with the camera, it has nothing to do with the class, it has nothing to do with anything except I made a mistake here. That mistake is crashing. Every time it does a try, it's crashing at this step. So the debugging gets a little hard when you're trying to write inside of a try and accept framework. So we're going to try to be real careful. And if we do have a mistake, then I'll show you how we go in and debug it. But that's kind of why I like to run it every couple of lines of code so that if I introduced an error, I kind of got it isolated. So we now have frame 3. I kind of became distracted there. I digressed, I think is the word, but I think it's important to understand and develop our troubleshooting skills. So what I'm going to do now is, if I am going to do face recognition, I'm going to want to frame dot. What I'm going to do is, first of all, I want to, how do I say this, that OpenCV operates in BGR. Face Recognizer works in RGB. I don't know if the color really matters, but we're going to go ahead and convert it to RGB. So frame RGB is going to be equal to CV2.CVT color, like that, CVT color. We're going to convert color. And then what are we going to convert? Well, we're going to convert frame, or we call it my frame 3. That's the one we're operating on, right? My frame 3, and then CV2.color underscore, and where are we going to go? BGR to RGB. So we're taking that my frame 3, which is in BGR, and we're converting it over to RGB. Let me look at that. I think that's good. Now, in order to go in a fast way, we want to scale that down now. And so what I'm going to say is frame RGB small, frame RGB small is equal to CV2.resize. And what am I going to resize? Frame RGB. So I have a frame, then I have a frame in RGB, and now I want a frame in RGB that is small. So that is going to be CV2.resize. Okay, we're going to do a CV2.resize. What do I want to resize? I want to resize frame RGB. Okay, and then I want to start at 0, 0, and notice that 0, 0 is a tuple. Okay, we're starting at the coordinate 0, 0, and then what scale do I want to scale it by? Well, fx, which is the scale in the x direction, is equal to scale factor. Okay, and then fy is equal to scale factor. And I strongly recommend scaling in x and y the same so that you don't lose your aspect ratio. But that's just me. Okay, that looks good. I'm going to go ahead and run this because, man, I hate debugging things inside of the try except way of doing things. Okay. And then Okay, we got a couple of frames not. Okay, boom, that is still working. But what I want you to see is, if you can see up here, did you see the first couple of times through the try loop, the first couple of times it errored out? I got a frame not available, and then boom, it started working. So that shows why we do. That's how the try and accept thing is supposed to work. All right, so we now have a frame RGB small, and so now what we want to do is we want to find the faces. Where are they? First thing is you find where they are, and then you find who they are. So to find where they are, it's frame, or it's face positions. Face positions is equal to CV2 dot, or that's not a CV2 command, that is a face recognition command. Okay, and face recognition, then what are we doing? Face underscore locations. All right, that's going to find the locations, and then we want to find the locations of what frame? Well, it is going to be frame RGB small, right? That's the thing that we just spent so much work getting ready, frame RG small. And now we are going to use the model equal CNN. Remember, there's the CNN model and there's the hog model. The hog model runs a lot quicker, but the CNN model is a lot more accurate and a lot more a lot more capable, but it's really slow. But we've got the Jetson Nano, and we've got those 128 cores that we're working on, so we're going to use the better model, and then we will close that out. So that looks good. And now what we got to do is that we just found all the faces. So it's going to return a list of coordinates, the location of the first face, the second face, the third face, the fourth face. So that face positions is going to be an array, and inside that array is going to it's going to be then arrays of the positions. Okay, so it'll be arrays inside of an array. Now what we want to do is, so now we have all the positions of faces in that image. What do we want to do now? We want to figure out who it is. So we're going to encode those faces. So we're going to do all encodings is going to be equal to face recognition dot, this time face underscore encodings. Okay, face encodings, and then what do we want to look at? Frame RGB. Okay, and where that's what we're going to look at, frame RGB. It was frame RGB small, I do believe. Frame RGB, let me get this right, frame RGB small. Okay, that's right. That's what we're going to look at. And where are we going to look? We're going to look in the face positions, because face positions tells us where the faces are. And now what this is going to go do is, at each one of those locations, it's going to encode the face. So this isn't figuring out who they are yet, but it's figuring out what is this face's encoding. Then we'll come down next, and then we'll compare the encodings we just did in this unknown image with the encodings that we of people that we know. I hope that makes sense. All right. And let's go ahead here and let's run this just to make sure that we don't have any errors. And I know this is slowing us down to keep running it, but man, I do not like having to find an error after I've written 20 lines of code in a try except. Okay, it looks like it maybe doesn't like something. Let's see here. Let me come down. It's not real responsive right now. Okay. That might be the normal error that we get. Let's give it a second. It should either start printing frame not found, frame not found, frame not found, or the window should pop up. One of those two things, but It's a little bit hung here, but let's give it a second. Okay, something it looks like is happening now. Really not sure why that thing is so unhappy. Okay, so it's trying to open up the windows. It is just incredibly slow here, and I can't imagine what I did that made it so slow. Sometimes maybe just the first time it takes a second, okay, but what you notice is it didn't crash, okay, and you notice that we're kind of getting up towards 5 frames a second. So let's see if we're still okay. Okay, we got a little delay in the cameras, but okay, I think the cameras are in pretty good sync now. All right, so I'm going to quit out of this, and I am not sure why it took that so long. Let's make sure that I'm doing the encodings on the right one, because it was acting like I was really looking at a big picture. So frame RGB is my frame converted to color, and frame RGB small is frame RGB at 0, 0 going down by scale factor. Then the face positions was in fact frame RGB small, and then the encodings was frame RGB small. I'm just making sure I didn't somewhere in there use one of the bigger images and then it just kind of brought the things to its knees, but it all looks pretty good here. And given that this was a little bit of a hang up there, I'm going to save the program just to make sure if we have to reboot that we have saved our work. Okay, so I do believe in fact now that we have done our recognitions, we have our encodings, and so now we need to go in and we need to figure out who those people are that are in that picture. And so what we will want to do is we will want to come here now, and there's an array called face positions, and we want to step through those places that there's faces and look at the encoding for that face and compare it to the people that we know. So we're going to have to step through, and so we're just going to step through. We'll step through based on face positions, and so we'll just call it top, right, bottom, left. And I know that's a very strange order, but that's the order that Face Recognizer returns the face positions in. It returns it as top, right, bottom, left, which to me is very confusing, but that's how they do it. And then as we step through that, we're also going to step through the encoding. So we'll call it face encoding. Okay, so we're going to have a position of the face, and then we're going to have its encoding, and we get those by stepping through the whole arrays that we found, which were what were those? What were those? You tell me what those were. Those were, and remember when we're stepping through two arrays, we have to zip them together. We're going to step through face positions. That's what we found above, and then all encodings. So this is the list of all face positions in the picture and all encodings, and then we're going to take those into an individual location, an individual encoding, the next individual location, the next individual encoding. So we're going to step through those using this for loop, and we will need a colon here for this to work right. Okay. And now we got to think about the possibility it might not recognize the person, and we need to give that person that's not recognized a name. So we'll just always start with name is equal to unknown person. Okay, we'll start with it being an unknown person. And now we're going to find the matches. So the matches, let's see, the matches is going to be doing face recognition. Okay, we're going to do face recognition. And what are we going to do? We're going to compare faces. So face underscore recognition dot compare underscore faces. And what are we going to compare? Well, encodings is all the people we know, right? That's what we loaded in from the pickle. All the people we know are encodings, and we're going to compare that with what? That person in the box, face encoding, right? That is the person that we're looking at this time through the loop is face encoding. Okay, so we're going to compare the present person face encoding with all the people, which is in encodings. Okay, so I'm just checking this, encodings and face encoding. Okay, now, all right, now what do we do? Well, if there is a match, matches is going to be an array. It's not this person, not this person, not this person. It is this person, so it's going to be false, 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 true, if it finds it. So if there is a true anywhere in matches, if there's a true anywhere in matches, we found a person. Well, we need to find which person it was. So we need to find the first match index. I want to find the index of that true location. So that's going to be equal to matches.index of true. So what is the position of the first true? And that's going to be the index of the person in that names folder. Okay, so now the name of the person is going to be equal to names, okay, of what? First match index, like that. Okay, so now I should have the name of the person that was found. I'm just going to see if this will run. I'm going to just do it real simple, print name. So if it finds someone, it should print it again. I want to make sure that this program isn't crashing. So we are going to go nice and methodical. We're on lockdown. We're in no hurry. We can take all the time in the world to do this in a methodical fashion. I think trying to troubleshoot programs with try except statements are what send a lot of budding engineers to the liberal arts school or the sociology department. Okay, we got one frame not available. Okay, that's good that we're not getting lots of frames not available. Hopefully this thing will pop up and maybe even it might find someone, but I don't know that yet. We are really running slow these days. I'm not sure why this seems to be running slower, but it just seems to take a while to start, and now it is really not happy. So we're getting lots of frames not available here. And so that is not good. So we have crashed this thing out somehow. Okay. So let's see. Did you guys see any mistakes that I made there? Let's see. I've got face positions, that all worked, and then we came here and we were inside of this. Okay, so let's just do it really methodically. So what I'm going to come up here is, and you guys, even if yours is working, look at what I'm doing. I want to see, is this right face encoding? That is in the for loop. Face encoding. That is not good right there. So you see it didn't know what that was, and so that could have caused the error. So let's try it again. But you see, the more code that you write before you run it, then the more places the problem could be. And if you guys have better ideas on troubleshooting, let me know. Okay, we're getting a lot of frames not available still, so it is still not happy. So let's go back and see what else we've got. So I've got top right, bottom left, face encoding, singular in zip. in zip, and I have face positions, and then all encodings. And then let's make sure that that all encodings is right. That all encodings should be what I loaded in up here. And I did not call that all encodings, I called that encodings. So I think probably that was my error. I didn't load it in as all encodings. So let's see if that runs. Hopefully this is making sense to you. It still does not like that. So let's see here. Let me take a look. Oh no, that all encodings was right. So, okay. That all encodings was right. Because what I'm doing is I'm stepping through the people. Okay. I'm stepping through. You know what I did not do? I did face positions, which is good. So I found the faces, but for some reason I did not recognize them, or I put the for loop in the wrong place. Yeah, I put the for loop in the wrong place. Okay, hopefully you guys saw that, right? And that needs to be a cut. Okay, I just put that in the wrong spot. So this makes sense now. So I find all encodings, so that's encoding all of the faces that are in the picture, and then I'm going to step through those. So I'm going to get an encoding for the first face, an encoding for the second face, an encoding for the third face. Okay, so that should work. And then I'm going to find matches between encodings and whatever present face I'm working on. Let's try this. And guys, I know most people that make videos go back and they edit them to take their errors out, but I don't do that, because if I do that, then you're never going to learn how to debug. So that is still not going to be happy. All right, so now what I'm going to do is I'm just going to see if it even likes that for loop. So inside the for loop, I'm just going to pass. I'm going to do nothing in the for loop, and I'm going to comment this stuff out. And this is going to be toggle line comment. So now I should just be able to see if this for loop call itself, it should just pass through that. But it shouldn't crash. I shouldn't continue to get those frames. Those frames not found or frame not available. And I am still getting it. So that would say that there is a problem in the for loop itself. So I have top right, bottom left, comma, face encoding in zip, face positions, and then all encodings, and that's all encodings. And so now this is quite perplexing. So what could be happening now would be possibly my camera's locked up and I'm not launching my camera or something because we killed the program ugly. So I'm going to close this whole thing, and now I'm going to fire it up again, because it could be that I have a problem with the cameras being tied up. So we'll try it again. Okay, I'm going to try one more time. I'm going to take that for loop out, because it was working before we put the for loop in there. And as it's running, I'm going to really be looking at this. Do you guys see anything that I did wrong? Okay, now what I think I have to do is I just think I have to reboot, because I think probably, maybe when we killed it ugly, we locked up one of those cameras, and when we locked up that camera, now nobody's happy. And again, what you're seeing is you're seeing how to debug code. You reach the point that you can't just keep staring at that one line of code trying to find a problem. Maybe it's something else, so I'm rebooting. Now, I'm going to be very, very distraught if after rebooting this thing doesn't run because it ran before I put the for loop in. Or the other possibility is you guys see the mistake I made and you're sitting there pulling your hair out over it, screaming at me, wishing that you could somehow message me what my problem is. Okay, so there we go. Now we're going to fire this code OSS back up. And of course it's going to probably have forgotten that. Remembered the window size pretty well. Okay, we're going to come back here, and we were working on Face Recognizer 8. Okay, and so now we're going to right mouse click and run. I really hope that it runs here, and then we can put the for loop back in by itself, and then we can put these other things in. Okay, we got a few frames not available. That's kind of expected, right? But it's not just keeping going, and so now we're probably doing those face encodings up there. First time, sometimes it takes a little bit to figure out where it is, and boom. Okay, so that's good. We're going to quit pretty with a Q. Okay, clean things up, and that looks good. Let me make sure I'm killing the right cameras. Cam 1, Cam 2, yeah. You see, if I was not doing this step correctly, that would cause a problem. Okay, that would cause a problem. All right, so now I'm just going to do nothing but the for loop, and I'm going to do nothing in the for loop but pass. Okay. So I'm just going to see, is that for loop statement right? But when we get in these situations, we got to tell ourselves it will work. Programming does work. We just have to be methodical in debugging our steps. And I'm kind of happy we got a few frames not available, and we are up here. It took a little bit to get the thing running, but that's okay. So now I'm going to quit out of there. Quit pretty, right? We quit pretty. So now this could not cause a problem, right? There's no way that could cause a problem. Make sure I got my tabbing right. And then we're going to check this pretty carefully just to make sure. So I've got matches, okay, is equal to face recognition dot compare faces. Face recognition dot compare facing, and we're going to do that on encodings, which is all of them that we know, and we're going to compare it to face encoding. I really think that that's true. I mean, I really think that that will work. And then we're going to say, if true in matches, then we got to make sure we keep our tabbing good here. Okay, so now I've got to make sure names is what I called it up here, and that's names, plural. Okay, and then first match index is first match index, and then I'm going to take that pass out, and let's run it now. Man, I hope that that simple stuff there did not cause a problem. It's looking encouraging. I got one frame not available. Okay, so far so good. So we're going to quit pretty with a Q. All right, and now there is no reason that you should not be able to print name because it knows who name is. So let's see. Now down here what we should see is we should see the name of the person that it recognizes just printed out. And if that works, then I think we're really on our way. All right, sorry that I froze. I will fix that. Okay, there we go. Okay, look at that. And if you look down here, it is recognizing me, and so that's very good news. All right. Let's see. So now we are finding the people. So that's good. So now what we need to do is we just need to go in and box and name the people. And so right now we know who they are. So now we've just got to go in and box them. But remember, we're working on a smaller image with these dimensions. We got to go scale it back up to the full image, not the scaled down one that we're doing the artificial intelligence on. So I got to go back and I've got to say top is equal to an int, because top is equal to an int, because you want to do this in ints. You want to do int and then top divided by scale factor. All right, now think about that. We multiplied by scale factor to make it smaller. Now we divide by scale factor to make it the full size again. And then I think the easiest thing, we're going to have to do top, bottom, left, and right. And so we'll just copy this, and then we're going to paste, and then we're going to paste, and then we're going to paste, and then we're going to say left, and left, and then right, and right. And then we're going to say bottom and bottom. Okay. And so that should not cause any problems there. So I'm not going to check that because I think that will work. And now we need to do our rectangle. So we're going to say cv2.rectangle, cv2.rectangle. And then what do we want to do? We want to go back to my original frame, my frame 3. That was that stacked image. And then what do we want to do? Well, we want to go from left top. Okay, remember we go left top. And then we want to go to right bottom. Okay, and then we want to go 0, 0, 255 for a color, and then comma 2. And guys, the hard thing about this is that like NumPy thinks in terms of math, which is rows and columns, but a lot of the CV2 thinks in terms of X and Y, which would be X and Y. So there's a reverse between NumPy and OpenCV and kind of the order they put things in. And then face recognize, it does, like it wants to describe a rectangle differently. And so you see, you've just got to kind of figure out something that works and then keep doing it that way. But now we're going left top, right bottom, and that should work for cv2.rectangle. And let's go ahead and check that. Let's check that. That is going to put the rectangle, I do believe, and then there should not be an error, and then we'll have to go in and we'll have to put the name on it. Okay, look at that. Boom. Dual facial. At least we're detecting faces, and we are face recognizing because my name was down there. All right, so that's good. Now, really, I think we got one more important line of code here, and that is going to be cv2.putText, and this is the one that I always mess up on. We're going to do my frame 3. I shouldn't be so negative. I'm going to do it right. What are we going to put on it? The name. Okay. And then we're going to go left and then top -6. So that's going to move it down a little bit so that it's in the frame. It's not getting out of the frame. Top -6 is going to move it down. And then we're going to want to put the font in there, and we're going to want it about 0.75 high, and we're going to want it yellow, which is going to be 0, 255, 255, and then we are going to want it a weight of about 2, like that. Okay, and then when we come down here, I think everything else should work. I really think everything else should work. All right, let's run this thing. I'm sorry that thing froze up, man. You know, it's just, I just don't quite have the computational horsepower I need to run all of this bandwidth that's coming into this computer. So sometimes it freezes, and hopefully it's not too big of a distraction for you. Okay, this is interesting. It's finding it, but it's not liking it. And so it is crashing out on that put text command. I knew always. And the downside is I can't quit pretty, so I'm just going to have to kind of crash it here. Hopefully that's not going to ruin my cameras now. But what did I do wrong in this put text? It's got to be the put text. So I say cv2.putText, and then where am I going to put it? I'm going to put it on my frame 3. That's not it. cv2.putText. I'm going to put it on my frame 3. That's right. I'm going to put it on name. That's right. And then I'm going to put it on left, which it knows, and top -6, and I did not close that parenthesis. Okay, but you see how easy that was to debug, because I knew that it had to be that line of code. If I just written all the code and run it and it didn't work, we would have been sitting here for a long time trying to find that error. I think this is going to run this time. Let's hope so. It's like the last few videos we've had a problem with that camera freezing on us. I need to, what I can do with the resources I have, I can just look over there more often so that it doesn't, oh, now it doesn't like that. Okay, let's see, that was, okay, now I had an extra one out there. So this closes that. Now I think it should work. At least we got an error that time. That was kind of nice. And you know what I'm really hoping is, I'm hoping that we don't have to reboot the computer again. And I just don't know how to free those cameras up if you kill the thing. Boom! Dual facial recognition. Look at that. And we are running at about 4 frames per second. Okay, we are running at about 4 frames per second. Okay, and that is just not too shabby. And let's see. Okay, that is looking good. That is looking good indeed. Okay, so look at that. Dual facial recognition at 4 frames per second from 2 different cameras. So let's just see. Let's just see if what else we can do with this thing. Let me take a second here to get over here. And let's see. Let me come over here. I'll get this for you guys in just a minute. And okay, let's see what else we can do. So it still recognizes me. And then let's see. I think I can bring this down. Okay, and let's run that video. Look at that. Okay, me. And okay, me and Donald Trump. Thank you, thank you. Okay, look at that. All right, let's see what else we can do. 1944. All right, let's come over here. Okay, and I need to back off a little bit. I gotten a little too close there. Okay, let me let this run. Okay, we got an unknown person. We've got, it's kind of confusing, Mike Pence and Paul McWhorter. I just a little surprised. Okay, but Dr. Burks it's pretty much recognizing Mike Pence. And then if I come over here, it's getting SEMA. Okay. Okay, Mike Pence it's recognizing. Okay, doesn't recognize the press as life forms. And let's see, Mike Pence it got. Anthony Fauci, You see that? Look at that. This is working 2 cameras, 3.3 frames per second. I think as it's getting more faces, it slows it down some. You can see it's having to do 4 faces, so we're down to about 3 frames per second. But this is pretty darn impressive. Okay, let's try one more little demo here. We'll come here and look at this. Unknown? Okay. I thought I'd trained on him.
Thank you very much, Robert, and
Unknown.
appreciate the opportunity
Okay.
to provide.
I did not train on those two. You know what it is that I should have run, before I did this, I should have run that training program again, and it would have gotten these two people. But you know, to train on a new person, just what you have to do is you have to come over to your, and let me go ahead and quit out of this. To train on a new unknown person, you just come over to your Pi Pro, and then we were working in Face Recognizer, and then we have demo images. You just need to come to the known, and you need to put some new people in there. And this one, I did not get those new people in there. Okay. Anyway, I'd done it, had it working, and I went to a different SD card. Long story, but that's why it didn't recognize those last two. All right, guys, this is pretty darn exciting to me. And I hope that you guys have had as much fun as I have in this lesson. And have you guys ever just lost your mouse, your cursor? I have 4 screens. And let's see. I wonder if I can show you my setup here. Okay, you see I have like screen, 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 screen up there, screen all over. You see this is a pretty big mess here. So we'll put it back on the Pi. And sometimes I lose my cursor on all these screens. But all right, guys, this is lesson number 47 in this artificial intelligence class on the Jetson Nano. And you're really doing artificial intelligence at this point. I mean, you are training a network on people, and then you can look at live video from multiple cameras, and you can find the people and identify them. And so that is pretty darn important. Let's talk a little bit about moving forward. What I've done is I've taught you in a mode that allows you to learn it. I took you step by step, and I did it through OpenCV. Why did I do it through OpenCV? Because OpenCV is easy to learn. You learn it step by step by step, taking baby steps, and then you get to the point that I believe you guys, if you've gone through these lessons, you can start from scratch and you can write your own program from your own applications. And so I really think that we've gotten you to the point that you on your own can do artificial intelligence. All right. I will say also that one other thing about this code, you could see, what do we like about this code? It works with multiple cameras. That's what we really like. What do we not like? What we not like is that we were only operating at 3 or 4 or 5 frames per second. It works, but we would like something to be faster and snappier. And I will say I came up, and I did a lot of different ways of doing this. Like I came up on this code, and what I did was I had streams, I had threads up here to do the facial recognition, so that while it's grabbing the next frame, it could have facial recognition being done on the old frame. So I tried to split and slice and dice this program a lot of different ways. But you know what? I was never able to get it to go faster than 5 frames a second. Now, if you wanted it to go faster than 5 frames a second, what you would have to do is you would have to make this number smaller, where you're scaling down to a smaller image, and then it would run a little faster. But at this point, using OpenCV and this library Face Recognizer, we've kind of hit a wall as far as performance goes. So we can't be operating at 30 or 60 frames a second doing the facial recognition. Now, this is what I think is probably really going on. Remember, we got the flash from the NVIDIA site, and then we put NumPy on there based on the NVIDIA instructions. And then we found the thing from some other guys about how to get Face Recognizer running on the Jetson Nano. And then we're running Face Recognizer inside of OpenCV using NumPy. There's all these different libraries. And what could happen somewhere in there, we might end up in a configuration where we are not taking full advantage of the power of the Jetson Nano. That it could be that somewhere in there we're doing some steps that are not being done on the GPU on those parallel processors. It could be that with all these libraries we end up somewhere where we have processes and functions being done on our main CPU instead of being done down there in parallel on our GPUs. So to move forward, we're gonna have to kind of go back, and what I'm going to do is I'm going to start teaching you how to use that NVIDIA framework. And the NVIDIA framework is not based on OpenCV. Okay, it's based on its own crazy world. Now the problem is it's very hard to learn that. And what I'm finding is that that there's like a very small number of handfuls of people in the world that really understand this artificial intelligence. And it's like they talk to each other, and there's like 100 words they use that no one else understands. And when they go in and they do like a getting started or absolute beginner tutorial, they use the first word and they say, okay, we're going to define this, but they define it in terms of one of their other secret words. So they define each one of the 100 words, but it's always in terms of one of those other words. And us normal people, it's just really hard to break into because we just don't even know what we're doing. We can run their demo programs and it's like, wow, look at this, look at what it can do. But then we can't sit down and write our own programs. All right. So how do we break into, we've kind of been doing the little boy artificial intelligence with the OpenCV. How do we start doing the big boy OpenCV, or the big boy and big girl artificial intelligence? We've got to start using that NVIDIA framework. We've got to start working in their universe. And this is what I'm going to recommend, or this is the direction that I'm going to go moving forward. I'm trying to decide now whether to start a new series, like, not go to lesson 48, but start a new series at lesson number 1. But this is what I see as a path forward, because it is just so hard to learn everything that they're doing. We're going to ease into it. And the way we're going to do it is we're going to keep using OpenCV, but when it comes down to the really important steps like finding faces or recognizing faces, when it comes down to those really computational intents, that's when we're going to hop over and we're going to use one of their routines, and then we're going to come back and do the rest of the work in OpenCV. And then we're going to gradually start learning more and more about the kind of framework, the NVIDIA framework. And so that's what we're going to do moving forward. And we should then be able to do things that we couldn't do in our OpenCV and face recognizer constructs alone. We're gonna kind of move into this new world, but I'm going to do it slowly, step by step. So each week, hopefully, we'll have a breakthrough where we do something that we couldn't do before and do something very exciting. So I have kind of rambled here a little bit, but I would really appreciate your feedback, because like I say, we're kind of at the point now that there's not a next logical step for OpenCV and face recognizer. I guess one thing that we could do is we could connect things to, we've got this, let's see, how can I show this to you? We've got this camera on a pan tilt servo, and you could start saying we'll track on a certain person. Like if you find Joe, track Joe, and if there's a crowd of people, track Joe in a crowd. There's things like that where you could combine what we've done so far with the pan tilt capability of the camera, or we could start accessing other of those GPIO pins where we did other things. We ran other things from the GPIO pins. But as far as just the basic artificial intelligence, there's not a next logical step we can do using OpenCV with face recognizer. So that's kind of me rambling about where I'm thinking about going next, and probably whether it's lesson 1 in a new series or whether it is lesson 48 in this series. I haven't exactly figured that out yet. What's the best way to go? I will say stay tuned to this channel, because I'm going to have some exciting announcements in the next few weeks, which I can't even say what the announcement is. It's so secret. But we've got some really exciting new stuff coming down the pike, and so you guys watch this channel, because I'll be in the next couple of weeks making bringing you some pretty exciting news that I'm not not allowed to say yet. Okay, so this is a good place to stop. And this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.